Right. Isotopes are atoms that have the same number of protons but a different number of neutrons. Same number of protons but different number of neutrons. If you have all these extra neutrons in the nucleus, it causes your nucleus to become unstable. So you get an unstable nucleus, which makes your nucleus break down and decompose, and we know that rate for different isotopes. That rate is a half-life, and how long it takes half of your sample to decompose. So how long it takes half of your sample to decompose is your half-life. The ones we're going to use are carbon 12, carbon 13, and carbon 14. Carbon 14, like any other carbon molecule, is going to have 6 protons and 8 neutrons. Having those 8 neutrons makes the nucleus unstable, and the carbon 14 breaks down. We don't really care what it breaks down into for our purposes, since we're kind of just introducing this, but you have done this before. We just care that it breaks down. Its half-life is about 5,700 years. So if the half-life is about 5,700 years, and you start with 100 atoms, after 5,700 years, you would have 50 atoms. But after another 5,700 years, you'd have 25 atoms. And after another 5,700 years, you'd have about 12 and a half atoms, if we could really have atoms. What if we started off with 100 grams? Well, after 5,700 years, you'd have 50 grams, and after another 5,700 years, you'd have 25 grams. The ratio of carbon 12 to carbon 14 is 1 carbon 14 to 1 trillion carbon 12. So a sample that's created today would have, let's say, 900 trillion carbon 12, therefore it would have 900 carbon 14. This is an unbelievable simplification of this process, but still, it's good for our purposes. It's only effective for up to 60,000 years. It's only effective for up to 60,000 years. After 60,000 years, you can't really use carbon 14 dating anymore. Okay, so let's look at some examples of this. Anytime you're solving these problems, you have to find out how many half-lives have passed. How many half-lives have passed? So you find a sample of charcoal that has 400 trillion carbon-12 atoms and 125 carbon-14 atoms in it. How old is the sample? Answer this question how many carbon-14 atoms would be here if the sample were created today. So, this sample were created today, how many carbon-12 atoms would be in there? Because carbon-12 is a stable molecule. It doesn't break down. It does not break down. So if there were 400 trillion carbon-12 atoms, how many carbon-14 would there be? 400 carbon-14. So there'd be 400 carbon-14, but we don't have that many. We have 125 carbon-14. So there's 125 carbon-14. How many half-lives must have gone by? So if you start with 400, after one half-life, you would have 200. After another half-life, you would have about how many? About 100. So we have about 125. So about 2 half-lives have gone by. We've had 2 half-lives gone by. Each half-life is 5,700 years. So 2 times 5,700 is about 11,400 years have gone by. So this sample is 11,400 years old. Another example, different way to look at it, you find a sample of tissue that has 900 trillion carbon-12 atoms. And you find it in a layer of dirt that you know to be about 17,000 years old. How many carbon-14 atoms should you find in this sample? So we still need to find out how many half-lives have gone by. If it has 900 trillion carbon-12, it should have, if it was born today, about 900 carbon-14. But we know that 17,000 years have gone by if it is in that sample. So 17,000 years is how many half-lives? One half-life would be 5,700. 2 half-lives, 11,400. 3 half-lives, 17,100. So if this sample of tissue is from that layer of dirt, there should be 3 half-lives have gone by. So 1 half-life goes by, there'd be 450 carbon-14s. 2 half-lives go by, 225 carbon-14s. 3 half-lives go by, about 112 carbon-14s. So our answer is that if this sample of tissue is from that layer of dirt that we know to be 17,000 years old, there should be about 112 carbon-14s. So that's the answer. Last one. It's a combination problem. You find a fossil that has 550 trillion carbon-12s in it. You find it in a layer of soil to be about 11,500 years old. How many carbon-14 atoms should you find in the sample? first of all, you have to figure out how many half-lives have gone by. 550 trillion carbon-12s. 2 half-lives have gone by because 11,500 is about 2 half-lives. So if 2 half-lives have gone by, I should have 550 carbon-14 to start. 2 half-lives later, 275 for 1 half-life, and then 150 37. So about 137 for that second half-life. So I should have about 137 carbon-14 atoms in the sample. But I actually found out that there's only 34 carbon-14s in there. I found 34 carbon-14s. So I know that if I had 550 carbon-14s, after 1 half-life, I had 275. After 2 half-lives, about 137. After 3 half-lives, 68. And after 4 half-lives, I have 34. So really, I know that 4 half-lives have gone by. Each half-life is 5,700 years old. So 4 times 5,700 is what? 2,800 years old. So that's 4 really good examples of how to use carbon-14 dating.